Hi, my name is Christoph and I'm a PhD student in the Aerodynamics group. My research is about experimental methods for aeroelasticity research. So let's get started by having a look inside the wind tunnel. Alright, let's take a closer look at what's happening here. We are standing inside the OJF, the biggest wind tunnel at TU Delft, with a cross-section of nearly 3 by 3 meters. At the exit of the wind tunnel nozzle, we have mounted a gust generator. As you saw in the video, we can move the vertical gust vanes and create an unsteady inflow for our test model. For this experiment, the model is a flexible wing with a span width of 1.75 meters. The wing is mounted on a force balance so that we can measure the force that acts on it. However, we cannot distinguish between different types of forces that act on the wing based on the force balance measurements. That's why we are developing a new measurement approach. For these measurements, we are using a robotic PIV system. It consists of multiple cameras and a laser optic fiber that are mounted in a compact housing and can be moved with a robotic arm. I will now explain how our measurement approach works. On the left, you can see the acquisition of a measurement. On the right, you can see the quantities that we are interested in, the three forces that are relevant in a dynamic aeroelastic interaction. The way our measurement approach works is as follows. With the robotic PIV system, we are acquiring images of markers we have painted on the wing surface and of helium-filled soap bubbles, which we use as flow tracers. The first step is to separate this information into flow and structure information. We achieve that by applying a high-pass filter to the series of images to get the flow and a low-pass filter to get the structure. The next step is to apply the particle tracking algorithm. A very nice feature of our approach is that we can use the same algorithm for analyzing the flow and the structural measurements. To relate the obtained velocimetry data to the forces that act on the wing, we have to apply a physical model. In fact, we need two different physical models for our approach, an aerodynamic model to determine the aerodynamic force and a structural model for the elastic and the inertial force. This is the result for the three forces that we obtained from the integrated measurement approach. To interpret this data, it is useful to recall the equilibrium of forces in Collar's triangle, which means that the sum of the three forces should be equal to 0. In the graph, we see that our measurement residual delta is not exactly 0. In fact, it corresponds to an error of around 10%. However, I'm still pretty excited about this result because this is the first time that it is possible to determine the three forces with only one measurement and data processing system. This brings me to the end of this quick introduction of my research. If you want to learn more details about my work, please have a look at the paper I presented at SciTech this year by scanning this QR code. And thanks for watching.